So the question is, how would you go about actually designing one of these proteins? Well, you'll start by getting a PDB file that has the XYZ coordinates for that protein. You would then open that PDB file in a Jmol environment, and you might display all of the atoms from that PDB file as space-filled spheres. You may color code those atoms according to atom type, and you might get a massive model that looks something like this. Now, frankly, that kind of a model is, in most cases, not very useful. It's too complicated. There's too much clutter there. It rarely tells an interesting story. But then you can do some interesting things in Jmol. You can color code that model not according to atom type, but by chain. And instantly then, you can convert the image of that protein in Jmol to something that has a little more information. You'll see an image like this then, in which the pink structure represents the protein, and then there's a green and a blue chain. Those represent the two chains of double-stranded DNA. So right there with that model, you could begin to talk about how a zinc finger protein binds to DNA. Again, this space-filled representation is not one that we use very often. So let's replace the space-filled spheres representing each atom with what we call a backbone model. And in the case of the pink protein, that backbone is going to simply trace the path of the alpha carbons around the length of the protein. So with the backbone model, you get an even better understanding of how the three zinc fingers in that protein are interacting with the double-stranded DNA. If your purpose is to only talk about protein structure, you might get rid of the DNA in this structure, and at the same time then we have color-coded the zinc finger with respect to its structure, its secondary structure. So now you can see three zinc fingers, and you can see each one has a red alpha helix and a yellow beta sheet. If you only want to focus on one of the fingers, then you could focus on the first 32 amino acids. You would have this image here. And finally, if you now wanted to come up with a model that would show how a zinc atom stabilizes that protein fold by being simultaneously bound by two cysteine and two histidine residues, you would end up with the final figure here. Now, as you learn to design a protein, you're going to have to learn the Jmol commands that create these different images of the protein in a Jmol environment. And all of the resources for doing that are linked to the website of whatever modeling program you may be following. So an interesting part of this design process, an interesting way to think of this is that you're not really starting with nothing and building up your protein. You're actually starting with everything, all of the atoms that are in that PDB file. And the key decisions you're making is which atoms are you going to not display, which leaves only a subset of atoms that create the structure that you really want to focus on. So good luck with your modeling project. I hope you have a lot of fun learning these Jmol designs, and again, the real trick here is to know in advance what story you want to tell and design your protein with features that allow you to tell that story.